All right, the recording has started. I will be posting this after the class is over with. I'll put it in the announcements. So again, I want to thank you for being patient with me today. I don't like to normally start class late, but I went to get my first COVID shot today, and it took a little bit longer than I expected. So, um, I didn't want you just showing up and not knowing what was going on. That's why I posted the announcement that we started a little bit late. So I'm gonna go ahead and share my screen. All right, and here we are. Somebody just came in, has a mic open. Okay, so if you'll mute your microphone, please. Um, so I just wanted to take a quick peek at the announcements because I mean I did post announcements for today, but that's not what I wanted to refer to. But I will remind you that the link to join in is in the announcements. And then afterwards there'll be a link to the video recording. But I did want to share this information with you. If I looked at the project information earlier, um, I was using a different app. I had out there information on the researcher app. Well, one student was actively looking for a project and wanted to use the researcher app, but when they downloaded it, downloading it was free, but when they actually tried to use it to find articles, they popped up a screen wanting a credit card, and it didn't used to be like that. You used to could use the researcher app to find articles at no cost. And so my concern was that I didn't want you having to pay for any articles, and so I wanted to find an alternative app. And so what I found was the RXiv mobile app, which is free to download, free to do a search, and then free to download a full article. So, because I wanted to make sure that you had adequate um, resources to find an article. So you can use the library, you can use this Hindawi website, or you can use this mobile app. You can use other avenues, but be careful. It might try to make you pay for an article, and I don't want you doing that. The last thing I want is to burden you with having to spend money to download an article. So I did go in and update the project information. Okay, and in the project details, it does show the updated information on the app. Okay, but if you're checking the announcements regularly, you probably saw that anyway, that I had updated the app. All right. So refresh my memory. I don't think I talked about the project in here. Am I right? Did I
Sorry,
talk
what's
about
that again, ma'am?
Did I talk about the project last week?
Uh, I don't think
I don't
so.
think so. I don't think
Yeah,
so.
I don't
Right.
think so.
Okay. So let me sorry.
I only remember you talking about it once, and I think it was in the lecture club. I don't think it was live.
Yeah, I talk about it in the lecture class, but there may be some people who have already taken the lecture. And here's what I'll do. I'll wait until the end to talk about the project. That way, if you've already heard it in lecture, the only thing is you're doing two different projects, right? So the instructions are the same. Please, somebody has an open mic. Please mute your microphone. Okay. So, if you're in lecture and lab, you're doing two different projects. So if you've heard the instructions in lecture, you don't have to hang around to hear them here as well, unless you just want to. And then you may have taken me for lecture, in a previous semester, and you've done the project for me, and you're familiar with how it works. Um, so I'll wait until the end and talk about the project. That way, people who are familiar with it don't have to hang around and hear it over and over again, unless you just want to. Okay. So I'm going to go into today's overview. So we're dealing with graphing this week. You know, again, for those people who, for whatever reason, might have missed us, first 2 weeks, I clicked on the weekly overviews, which is a breakdown of the assignments, because I'm still getting emails from folks saying they don't know where to look for stuff. Well, that was week 1. And so, you know, this left menu, you need to, you know, spend some time making sure you're comfortable with the layout of the class, because I have people clicking on the calendar or on the to-do list and looking and emailing me saying, I can't find anything. I see the lab report instructions, but what am I supposed to be using to do all that? And I'm like, okay, somewhere you didn't read underneath there, you know, that the weekly overviews are where you find the assignment stuff. So again, it's important that you know, that you are familiar with how things are laid out and structured in this class. The left menu is pretty much your guide through this class. All right. So this week we're going to be dealing with graphing, and here are the objectives for graphing. So some of you might have done graphing in a math class. You know, maybe you had an algebra class, or, you know, a pre-algebra class, or some type of math class where you had to, you know, utilize graphing. Well, you'll see here as you get into this whole graphing business that graphing for scientific purposes is much more detailed. Okay. And that is because when you draw a scientific graph, you're trying to communicate something about your data, your analysis, or an experiment that you perform. Okay. So graphs are very useful for that in a laboratory setting. And so what I'll be doing today is explaining to you some information on how you do a proper scientific graph. You know, and so you want to get this graphing process down and be able to do a good graph, because you'll be using this skill for the remainder of the course. So the reason I have you practice graphing now is so that you can get comfortable with that particular skill, because you're going to be having to graph throughout the lab. Throughout this course, you'll be doing graphs, and each time will be an opportunity for you to convince me that you know how to do a proper scientific graph. Okay, so last week we looked at error analysis. This week we're focusing on graphing. 2 major concepts, 2 major skills that you need in this course. All right, so you can see all these objectives relate to graphing, and these are the kinds of things you'll be able to do if you successfully complete the activities. And of course, you should be going through the required readings and viewings materials to help you with the graphing business. So here are the activities that you'll have to do for this week. I'll come back to the project, as I said, after we're done. And then it tells you to go and look at the required readings, viewings first. So I have some graphing practice there. This practice is totally for you. It's not anything you turn into me. You can play around with it. There's some videos. There's some information on best fit lines, which I'll talk about that when I explain the experiment that you have to do. Okay. And so there are tools that you have available to you to help you with this whole graphing business, in addition to you know, the information that you'll get while you're doing the experiment. All right. So any questions on that so far? Okay. So now I'm going to cover the experiment handout. Okay. All right. So this is the experiment handout. Of course, as with everything that we do in this class, I want you to be aware of the reasons why I have you doing it. So, you know, of course, this graphing is a key element of this class, and because you know, it falls right in line with the goal too, to teach you some systematic laboratory techniques. Because folk who work in real laboratories, they have to produce graphs about the, you know, the data that they're dealing with. And so if you're in a lab setting, you need to know how they go about doing that, right? And so it says here, for experiment number 2 on graphing, go to the following website. So I direct you out to a website. Okay. All right. It says, if you keep getting an error, a page not found, you might have to copy and paste this link, or if all else fails, you can you might have to type it, or you can download the document. You know, when you're on Canvas, if you click on the item instead of the little looking glass, see, clicking on the looking glass opens it up in Canvas. But if you click on the link itself, it'll download a copy. So if you have some difficulty, you might have to do that. It depends on the browser you're using. If you're using Chrome, you won't have any issue with it, okay? But, you know, I know folk use other browsers. So if all else fails, cut and paste is your friend. So it says, read and follow all instructions and information provided. Do not worry about the quiz that is being mentioned. You do not have to take any quiz. What am I talking about? You see, because the very first thing it tells you what it work through all of the exercise, didn't take the quiz. And I just told you what? You don't have to worry about taking a quiz. That's not relevant for what you're doing here, okay? So it does say, read and follow all of the instructions and information provided. So you're going to carefully read each section and do what, if it tells you to do something, that's what you're going to do, okay? So this thing is broken down into 7 sections, okay? In each section, they give you some instructions. You follow those instructions, and then that's what you're going to do to work through the experiment, okay? So the experiment handout tells you to go out to the website and follow the instructions that are on the website. It says complete all required activities and answer all questions. And then I give you some information on graphing that you know, you will, you know, be able, that will be helpful to you while you're doing this graphing experiment, okay? So this is some additional information in addition to what they provide for you on the website, because they do give you like background information and that kind of thing, okay? All right. So I'm going to cover this background information with you, and then while you're reading, you will read and follow any information that's given on the experiment website. Do all of you understand that?
Yes, ma'am.
Okay. Because I get students, a lot of times they're looking at this handout and they're like, I don't know what to do. Well, if you click on the website and go there, that's what you're going to do. I have sometimes students having a difficulty making the distinction between the experiment handout, which is a set of instructions, and the experiment website, which is where you go to perform the actual experiment. Okay, 2 different things.
So all we have to do is basically follow the instructions on the website. Just don't take the quiz.
That's correct.
All right.
Yep, plain as that. All right, so now let's finish taking a look at this stuff, and then I'll tell you what you're going to turn into me next week. I mean, excuse me, by Saturday. And then, you know, for those people that need to hang around and hear about the project, we can do that, okay? All right. So it says here, the presentation of data in the form of graphs is extremely useful. And then the question I would have is, okay, well, why is it useful, right? Well, because when you utilize a graph, you have a visual feel for your data, okay? So in here, when we talk about a graph, we're going to be talking about a graph on a 2-dimensional surface. So let me show you what I mean, okay? So and one of these, when they ask you to plot a graph, let me see, I think I skipped it. Yeah, there's a link to some free graph paper. So here, this is what we mean by a graph. We're going to use a two-dimensional grid. What do I mean by two-dimensional? You got horizontal and vertical, okay? So, you know, in math class, you say X and Y. On this sheet of graph paper, you can draw X and Y, okay? X is always the horizontal, Y is always the vertical, okay? All right, so let me see if I can do this, if I'm working correct. Bear with me for a second. I was doing something for another student, so I need to close that out just for a minute. All right, so now let me take a screenshot because I want to actually draw on this graph paper for you. So bear with me, okay? Can you see that?
I can see the blue or the
The
graph.
only thing I can see is the graph, no drawing.
Yeah, okay, hang on. Let me stop sharing. Let me share again to make sure. Yeah, now I'm going to draw on it. You shouldn't see any drawing because I haven't drawn anything. Okay, so now when I say your graph, you know, you got your horizontal, and I apologize, I don't have a straight edge. Okay, you know, you got your horizontal that you call X, and then you'll have your vertical that you call Y. Okay, and in a math class, that's how you typically do X and Y. And the X is your horizontal, it's the independent variable in your experiment. Okay, and Y is always your dependent. Well, okay, so you're independent and you're dependent. Okay, let me try to fix that because I know when you're learning, if I don't spell it out exactly, it might not make sense to you. Okay, so I'll go back to my pen here. So dependent. Okay, so that's what we mean when we say a graph. Now, you know, the reason why this is important is because you can represent your data from your experiment utilizing a graph. Okay, you could put data in a table for sure, right? You could have data in a table, just like last week when you did the error analysis, you had data tables. All right, but the benefit of having a graph is that you can visually see and get a feel for your data, meaning you can see pattern, you can visualize patterns in the data. So you can see if it's linear, you can see if it's non-linear, you can see the maximum point, the minimum point. You can see if it changes direction. You know, you can get a kind of a feel for the data in a visual fashion that you can't get if you look at a table. So if I gave you a table of like 1,000, you know, or more data points, and I asked you, well, what's the biggest value? Well, that might not be easy to just pick out at a glance, right? But if you're looking at a graph, you can definitely tell me what's the biggest value, because graph is very visual. All right. Now, there is a trade-off because, I mean, you can't get more precision by writing numbers down in a table because you can have more and more and more and more decimal places, right? Okay. But that, you know, the patterns aren't visible in a table the way they are on a graph. The graph is limited. I mean, I think everybody would agree that the sheet of graph paper that I brought up, it has a limitation. You don't have an infinite size for a sheet of graph paper. I mean, you know, when you go, you can get one that's pretty big, but it ain't going to be infinite. And so that means that there's error associated with even drawing the graph, because I mean, there's the sheet of graph paper itself is limited. All right. But you can get more precision with a data table, but you can't get the visual feel for your data when you utilize a data table. All right. And just as I said, in here, we don't do three-dimensional. We don't do X, Y, Z. We stick to two-dimensional graphs, just like I drew. And you have X and Y, which X is your independent variable increasing from left to right, and it goes on your horizontal axis. And then your dependent variable, the one that you can't control, it increases from bottom to top, and you know, this is the one typically you think of as the one that you have the quantity that's being measured. So, and then the independent variable is the thing that you get to adjust. So if I adjust the temperature, what happens to this? You know, or you know, any as time increases, what happens to the distance? Well, you can measure you know, the time you can interval you can decide on. Is it an hour? Is it a day? Is it a month? But hey, you know, the amount of sunlight, you don't get to control that. You can just measure it. Time of day versus the amount of sunlight. Well, you can decide the time of day that you want to take the measurement, but you can't control the amount of sunlight. You can only, you know, measure it. All right. So dependent versus independent. And you will get an opportunity to utilize the idea of doing two-dimensional graphs in this class. That's a key skill. Okay. And so this website is designed to guide you through this process. All right. And I'll talk about it a little bit more here in just a moment. What, you know, the process of using this website. What are you going to do? All right. So the rest of this is a set of tips. You know, like I give you pointers on how to do a good scientific graph. Okay. And so the first things it tells you is plan it so to make the best use of the area, the available area, and present the data in a manner that will be clearest to the viewer. So let me say this to you up front. In this class, you are not allowed to use computers to do graphs. You must do them yourself. So go buy you a $1.09 pack of graph paper or print out a bunch of these free graph sheets here. And then when it's time to do your graphs, you must use the graph paper. Okay. So
I got a question.
Yeah.
I have an iPad. Can I manually draw it on the iPad with like graph paper? Like on the iPad?
If you just saw what happened to me when I tried to draw it, right? You can't draw straight lines real good and all of that, right?
Uh-huh.
Yeah, so you know the neatness matters. It's
Okay.
not just a sketch, it's an actual graph that reflects the data that you've measured and the analysis that you've done in your experiment. So it's not like a math class where you can just sketch X and Y and draw a straight line. No. So I don't know anything about an iPad. I've never used one to do graphs, but if it doesn't allow it to, if it doesn't make it look like you actually drew it yourself, if it doesn't look like, you know, like you got to break out the pencil and draw the lines and, you know, and the points and stuff yourself, if it doesn't do that, then you can't use it. So my suggestion to you is go ahead and invest the, you know, go spend $1.50. That's about, I apologize, you're gonna have to spend $1.50 to get some graph paper. Or you don't have to spend anything, just print these out and use them. The thing is, I want you to have a grid that's pre-printed, you know, because I don't want you freehand drawing a grid, and you can't use computer paper that's plain or lined writing paper. No, has to be graph paper. Okay. And then so it tells you to plan out your graph. Do you need to orient the paper portrait or landscape, right? So I always say, do you need the long side on the Y, or do you need to turn it and have the long side on the X? You need to decide that. And you want to spread your graph out so you use as much of the paper as possible. It is no value in having this whole sheet of graph paper and you draw me a itty bitty graph down in the corner. Okay, that's no good. Or you draw a little graph right in the middle and all this space out here. No good. You got to draw me a graph that utilizes the bulk of the sheet, except you leave a space for labels and a title and a legend if need be. Okay. So, you know, let me stop the share and see if I can share again. Then my paint, right? So you see here, I'm using the bulk of the sheet of graph paper. So you got to have a title, you know, and let me just tell you, the way a title goes, you always put the dependent first in the name, and then, you know, versus the independent. Okay. See, that's the difference that you face when you're doing a scientific graph. In a math class, they don't care what you call it. But in a graph that's dealing with your data or your experiment, the title is your dependent versus the independent. Okay. And then, you know, of course, when you draw your data points, you want to draw a nice sharp, you know, data points. You don't want data blobs like that. See, that's wrong. Nice sharp data points. Okay. When you draw a line, I don't have a straight edge here, but you draw, you know, when you draw a straight line, you use a straight edge. Don't freehand draw it. I can't help it here because I don't have a ruler, okay, or a straight edge T-square or anything like that to draw my straight line. But when you do it on your paper, you need to use a straight edge, because if you freehand draw your straight line, I'm gonna take off points. If you play connect the dots, so let's say, for example, you had data points. Okay, I'm gonna make them a little bit darker so you can see it here. Okay. And size, that's the biggest size. Okay. So let's say you had data points that did something like this. Let me just erase this thing. Okay. And you got ready to draw your line. And if you did this kind of thing, oh, sorry, I got the eraser still on. Okay, so if you did this kind of thing, which a lot of times computer software will do, which is why I don't let you use it, because a lot of students don't know how to get around it in the beginning phases of a, you know, class. If you did something like that, that'd be totally wrong. Totally wrong. What you draw is called a best fit line, which cuts through the middle of your data. And in this class, you're not allowed to use computer software to graph, and computer software will draw the best fit line for you. But I want you to have the practice and experiment of actually doing it and understanding what it means. The best fit line represents the average of your data, and that's why it cuts through the middle of all of your data points. Well, when you draw the best fit line, you're going to be eyeballing it. And the way you eyeball it might be a little bit different than what somebody else eyeballs it to be. Same data, but you know, the truth of the matter is If I gave two different students a sheet of graph paper and I said, draw me a graph, their graphs are not going to be identical. Okay. And so, because of that and because of the limitation of the graph paper, that's why you will have some error associated with your graph, because you can't do it to an infinite level of precision. Okay. Is your best fit line going to be the one that a computer would make? Probably not. Is that why I'm having you do it? No. I'm having you do it because you need to understand what a best fit line is and how you then use it. Okay. So, let's see. Let me go back and I apologize. I have to keep swapping the share, but that's the only way I can convey this information to you. All right. So, again, make sure that you use as much of the sheet of graph paper as possible. I always tell students in this class, 1 graph per sheet of graph paper. Okay. And I know the habit for a lot of students is to put the data table on the graph. I would prefer that you use the graph paper to make your graph and put the data table somewhere else. It can be on the back of the graph, but not on the graph. And also, you do not, unless you specifically directed to do so, you do not put more than one graph on the same sheet of graph paper. It's 1 graph per sheet of graph paper. Okay. And that way, you can blow it up as big as possible because you only got 1 graph on that. Use as much of the paper as possible. The only thing you have to do is leave space for labels. You got to label your axes with proper units, and you have to give your graph a title. And also, if it's linear, for academic purposes, for learning purposes, so that I know how to do it, you calculate the slope on the graph. And I'll talk about that in just a moment. Okay. Choose your graph paper. Well, I just told you, go get you about $1.50 pack of plain graph paper, or print you, 10 sheets of this, whatever you need, however many you need. And then when the time comes, you have your graph paper. Okay. I talked about drawing the points with a nice sharp pencil. If you have to scratch out, start over. Because if you give me a graph with scratch outs on it, I'm going to take all your points. Okay. Neatness matters. I don't advocate doing graphs in pen. Some students do it. If you mess up, ain't no scratching out. And even if you're doing it with pencil, if you have to erase too much, then it's not going to be clear to the reader. Remember, a scientific graph is meant to convey information about your experiment. If that is messy or unclear, how in the world can anybody trust your results? Okay. All right, so it talks about the idea of the best fit curve. You don't play connect the dots with the points. Make sure that you label your axes. If it's linear, use the straight edge to draw the straight line. Okay. If you're using any special markings, you put a legend. So, for example, let's say I had another. I had to do 2 graphs in one. Okay. And let's say, one of them I drew with the red line. Well, I need a legend over here to explain what's the difference between the red line and the blue line. I mean, the black line, right? You have a legend. Okay. That's only in the event you have special markings that you want to explain. So I have, something that told the black line is this and the red line is this, whatever it represents. Okay. So I'd explain what's going on. Okay. Because remember, you're doing this for people who don't have a clue. And so when you put your data out there in the form of a graph, it has to be very clear and understandable. All right. All right, check the overall appearance. As I said, neatness matters. You can skip section 6 because you are not allowed to use computers. So it doesn't matter what they say in there. You can't use it. Okay. And then this screen right here, let's see if I can zoom in a bit. All right. Talks about how you calculate the slope if the graph is linear. Most of your graphs in here will be linear. This experiment that you're about to do on graphing, there's only one graph that's a parabola. And outside of that, you won't graph a parabola anymore in here because this is an introductory class and your graphs are primarily linear in this class. Okay. All right. So this shows you, you got your X, you got your Y. You give it a title. Notice they plotted the data points. Okay. And then they drew the best fit line between them. And then to get the slope, since it's linear, if the graph is not linear, you do not calculate slope. Okay. So if the graph is linear and you're going to calculate slope, you always pick 2 points on the line to do the slope calculation. You never pick your data points. Okay. Now, if your data points are actually on the line itself, then okay. But you always pick 2 places on the line itself, not your data points. If you use your data points to get the slope, what you're really doing is introducing more error. Whereas if you use the line to get your 2 points to calculate the slope, you're using the average. And last week we clearly talked about the idea that an average value has less error because an average means you've measured something more than once and you're taking an average. Okay. So, because remember we said if you only measure once, the best you can do is plus or minus half of the small scale division. But if you measure more than once, how do you know you measured more than once? You got more than one data point. So the average of those, which is your best fit line, has less error. Okay, so you pick 2 places on the line and you write, when you have a graph, ordered pair, X, Y, number 2, X2, Y2. And then you're going to use those points from the line to calculate your slope using this formula. Okay. And normally when you're doing, just work or whatever, you wouldn't not necessarily put the slope calculation on the graph, but just because we're in a learning environment, I'm asking you to do it for me. If it's linear, show me your slope calculation on the graph. Okay. Data table, don't put it on the graph. Slope calculation, put it on the graph. That way I can see right there what points did you pick and what calculation you did right there with your graph. I don't have to go and look somewhere else to see. Now, how did they calculate this slope? Let me go back and look at this graph. It's right there in front of me. That's for me. I'm asking you to do that so that I can grade you effectively. Okay. Under normal circumstances, you don't have to put the slope calculation on the graph. You just write a little thing, maybe in a legend, M equals, and everybody knows that's the slope. Okay. So what I've done for you in this handout is I've simplified and summarized the graphing rules. This is kind of like a checklist. If you can check off each one of these as you're doing the graphs, then you know you have a good, strong scientific graph. Okay. What are your questions on the background? It's just background. This is not the actual experiment. This is an experiment handout, which gives you directions and information. Anybody, unmute your mic, ask your question. All right, so much for that handout. Let's look at the actual experiment website. So we've looked at the experiment handout, which tells you to go to this website. So what are you going to do when you come out here? As I said, slow down and read. I know the habit is to want to jump right in and do something. First thing you need to do is slow down and read. Read the information that they give you in each section. Okay? Each section. And then start to do whatever it asks you to do. Okay? So one of the first things they ask you to do is complete this data table. And then after that, they ask you to make a graph for this data table. And then they ask you to calculate the slope. Well, remember I asked you to calculate the slope on the graph, right? No problem. Next set. Here's another data table. Next, they ask you to make a graph for that table. Then they ask you some questions, tell you some things to do. Okay? Next set, another data table. They tell you to make a graph. Somebody got to open.
We're still looking at the graph paper you were talking about.
Oh, okay. Well, gosh. Okay, I apologize. I'm going on, and I didn't realize that. Okay, so now, we finished the experiment handout part. Everybody good with that?
Yes, ma'am.
Did I lose anybody in looking at the experiment handout? Because I covered this stuff here and I talked about calculating the slope. Did all of you see that part?
No.
Oh, wow. I apologize completely. Let me go back. So I got to step number 6, which talks about using the computers to draw graphs. And I told you you can't do that. So now what the next thing I did was talk about the idea of drawing a slope. Okay. So imagine that you have a graph, X and Y. You plot your data points. See, they explain that that's their legend right here, for example. They're telling everybody that that's a data point. Okay. Now they do need to give their graph a title. And in this case, it would be Y versus X because that's what they named them. Okay. In your graphs, it'll be like something like circumference versus diameter. That'll be your title because the diameter will go here and the circumference will go here, or area and radius, whatever. Okay. And then once you have plotted your data points, then you draw what's called a best fit line that cuts right through the middle of your data. So you can see from this visual that this line is actually the average of your data points. And since it's the average, it has less error. Because we learned about that last week. Okay. And now since we want to, the graph is already limited. So we want to do things in a way that we minimize the error as much as possible. So instead of using the data points to calculate your slope, in math class, you would use the data points to calculate your slope. In fact, if they ask you how to do it, you know the point slope formula, y2 minus y1 over x2 minus x1, and you use actual points off the line to do that. Well, you use actual data points to do that, but not in this class. When you draw the best fit line, that's what you use to get your slope. Okay. So now you pick 2 places on the line that you've drawn, and you mark the X and Y, values for those 2 points. Okay. And then you put them into this formula to do the slope. And as I stated, because this is a learning environment, when you do your graph, make sure you put the slope calculation on the graph. You can put the data table on the back, like on the back of the graph or in a different place. Fine. I don't care about that. I mean, it has to be correct, of course. I care about that. But I don't want data tables on your graphs because I want you to get in the habit of utilizing as much of the graph paper as possible. And if you put data tables on the graph, it means you got to make the graph smaller. Okay. Do all of you follow that?
Yes, ma'am. But so we only take we're only trying to find a slope if it's linear, right?
Of course, you cannot find a slope of a parabola.
Yes, ma'am. Thank you.
Right. Yeah. Okay. And so, um, when it's linear, and most of your graphs will be, you put the slope calculation on a graph. Show me. All right. And then, so what I've done now is I've kind of summarized the graphing rules for you. This is like a checklist, 1 through 7. When you're drawing a graph, you first check, I got a title. Check, I label my axes, I put units. Check, I got the independent on the horizontal, got the dependent on the vertical. I can't tell you how many times people reverse them. They put the X on this axis and the Y on this one. Well, you might get away with that in a math class, depending on what they ask you to do. But you won't get away with it in a science class, because that means you're communicating your data in a reverse way. Okay. All right. Data points must show on the graph. So, while I want them neat, sharp, use a nice sharp pencil to draw them. Use a straight edge to draw your straight line. Okay. Don't worry about a French curve. You don't have to do that. I mean, we're not doing S curves or anything like that. All right. Make sure you use your scale. Use as much of the graph paper as possible. Choose counting intervals. Are you going to count by 5s? Are you going to count by 2s? Are you going to count by 10s? Do you have to count by hundreds? You have to use an appropriate counting interval so that you use as much of the paper as possible. Okay. All right. And then determine the slope from the straight line, not from the data points. Okay. And then show your slope calculation on the graph paper. All right. So that's kind of like summarizing the graphing rules. So that's the experiment handout. I think I got you caught up now. Am I right? All right.
Yes.
Okay, so now let's take a look at the actual graphing website. Okay, so this is the experiment website. Experiment handout, experiment website, right? So what you're going to come out here and do is you're going to slow down, take your time, read the information in each section. Okay, read the information. And then when you get to section 4, that's when you're going to actually start to do the data that you need for the experiment. So you're going to complete the data table. And then below that in section 4.2, it asks you to make a graph for this data table. And then in section 4.3, it asks you to calculate the slope. And remember, you're going to calculate the slope, but you're going to make sure that's on the graph. Step 4.4, you're making another data table. And they explain to you here how to do it. I can't tell you how many times I get an email saying, well, I don't know what to put in this table. Well, if you slow down and read, it tells you right here. Okay. Then step 4.4, you're going to make a graph for that table. Step 4.5, calculate the slope for that graph. Section 5. So you got some information that you need to slow down and read, and then you're going to be filling in this table. Please pay attention to units. Okay. Then 5.4, you're going to make a graph for that table. All right. Now, that takes you then to section 6. Read it, complete the table, make a graph, calculate the slope. And then in section 7, you have 10 questions to answer. Okay. So when you work through this, by the time you're finished, you're going to have 4 tables, you're going to have 4 graphs, and the answers to these 10 questions. Are there any questions about what you're going to do out here on this website?
No, ma'am.
Okay. So read and follow that, complete it. Okay. All right. So that takes care of the experiment website. Experiment handout, experiment website. Let's talk about what goes in your lab report. Okay, so after you've completed the experiment, then this talks about the lab report. So each time I explain to you what I need you to turn in. It says for lab report number 2, graphing, read and follow all instructions and information provided in the experiment handout. Complete all required activities and answer all questions. When you are finished, you should have 4 tables, 4 graphs, 1 for each table, and the answers to the questions in section 7. This complete packet is to be turned in lieu of the standard lab report. So you are not going to write a lab report that has abstract data analysis conclusion. What are you going to turn in? 4 tables, 4 graphs, and the answers to the questions in section 7. Do all of you understand what you're going to turn in?
So the experiment basically is the lab report.
That's correct.
Okay.
Thank you for saying it so plain, because no matter how many times I say turn in 4 tables, 4 graphs, and the answer to the questions in section 7, I never get somebody who asks me, do we need to write a lab report?
Yes, ma'am.
All right. Okay. So y'all good on what you have to turn in? All right. So now once you have done the experiment, you've done the lab report, then you're going to do this post lab. This post lab, you're required to come in, answer these 5 questions. What you do, you hit reply, post your answers to these 5 questions, and then it tells you that you have to comment to 2 of your classmates posting. And please do not tell them, I like your answers. Oh, we got the same things. That's not what it asks you to do. It asks you to engage your classmates in a way to have an honest discussion about what they've done. Okay. So if you notice that something they've done is like, wait, number 4, you reverse them, you calculated it backwards, or you don't have units. You know, like when they post their answers, your job is to go in and critique and try to have an honest dialogue. Well, maybe they did, you know, have, when they answer the question, they have some things there, but they don't, you know, you explained it one way and they explained it another. You're both in essence correct, but you're like, hey, you know, I noticed that you focused on this aspect of the question while I focused on this. You know, cool, because between the 2 of us, we've given a real thorough answer. Imagine you were in the classroom and I said, I want you to break down in small groups and I want you to work together to do questions numbers 1 through 5. And then when you finish, each one of you is going to turn in your answers to the question. That's what this discussion is supposed to be about. We can't do it face to face. So the only way I can do it is if you put your answers and then you go back and try to have a discussion with your classmates about theirs. And you don't have to reply to all of your classmates. You don't even have to reply to 5 of your classmates, because in a classroom, you might have 5, 6 people to a group, right? All right. All you have to do is pick 2 classmates and talk to them about what they posted. Well, why did you answer? What were you thinking when you answered question number 3? Help me understand what you were thinking, because this is what I thought. Do you understand? So if you give me like 3, you know, like, you know, 1 sentence, hey, we got the same thing, keep up the good work, you're going to get 1 point from me. Because I'm going to tell you, that's not a discussion. Okay. Do you follow?
Yes, ma'am.
All right. So that'll take care of the experiment, the lab report, the post lab. I give you instructions on how to turn the lab report in. Please pay attention to this, because I'm still getting students that are sending me things in the wrong file format. I'm getting pages. I'm getting HEIC files. I don't even know what that is, but I get a bunch of them. You know, all kinds of formats that I can't do anything with. So please follow the acceptable formats that I provided to you here, so that when you turn in your work, you know, I don't have to email you back and say, I can't open this. please resend it. Please redo it and resend it. Okay. All right. And then, of course, class questions. You can drop a line in the class questions forum. The goal here with the class questions is that, classmates are working and, kind of helping each other. It's another tool for getting questions answered. I would prefer if the primary answers come from students, but I do go in and check it. Okay. All right. So you have these items on your plate to get done by Saturday, 11:59 p.m. What are your questions? All right. So for those people who are in a lecture class and have already heard me talk about the project, or you've even done a project for me before, when you did have me for lecture, and you don't need to hear my instructions again because you know what you're doing, you're free to go because I don't have anything else if you don't have any questions for me. Those people who are new at this, or who are not in my lecture, and you want to go ahead and leave because you're going to hear the same stuff in lecture, feel free. You're free to go unless you just want to hang around and hear it twice. Okay. So I take it that the folk who are here want to know about the project. All right. So let me first guide you on how you can get to this information, because there's multiple ways. In the weekly overviews, if you look, whenever you have a deadline regarding the project, you'll see a link to it, link to the project. Okay. So you could click either of those and you'll get to the project. You could go in the syllabus, and there's, because there's a listing of the assignments, you'll find a link to the project there. I've put in the weekly overviews themselves. So within this week's overview, there's a link to the project because I plan on talking about it. Anytime I plan on talking about the project, I'll put a link to it. Okay. So you'll know when I'm going to talk about the project. If you look at the overview, oh, she's going to talk about the project today because there's a link to it. All right. And then finally, if you click on assignments and activities, there's a link to the project. Because remember, assignment and activities explains to you each of the type of assignments you have to do in this class. All right. So if you click on project information, it brings you to this screen. And there I remind you of the deadlines that you have on your plate for this project. And also I give you some background as to why I have, how many points it's worth, how you're going to submit it, that kind of thing. Okay. So all that information is here. What I want to get into today, we'll look at some of this other stuff later because it's not relevant now. I'll go into project details because I want you to know how to get started. Okay. So, of course, anything I have you do in this class, there's a reason for it. And this project is designed to boost your knowledge of physical science first, because if it ain't about physical science, we don't need to be doing it. But also, it's to boost your information literacy skills. How do you find and evaluate resources? Because there's a lot of junk out there on the web. How do you know what is useful information out there? And so you get a little bit of practice with that in this class by doing this project. And then also, writing a summary, okay? Relating the material to what's covered in class, okay? So how does I'm sorry?
So your summary is about the article that you pick, right?
Yes, and what I'm going to tell you today is the particulars of that article. What articles are you allowed to use, or what type of article are you supposed to be looking for? That's what I'm going to explain to you here in just a moment. Because it's not just any article. Okay. And then the last thing you'll do with this project is focus on, it's kind of an introduction to APA format. Okay, just a brief, just some minor things to expose you to APA format. Okay, and we'll talk about that later, because that knowing APA format is not going to help you find the article. So let's talk about the article and how you find it. All right, so it says a peer-reviewed research journal article is to be read and summarized in your own words. So this peer-reviewed research journal article, that's the key. All right. So let me explain what that is. So, there are scientists out there doing research, and, a very important component in research is to effectively communicate the work that you've done. So there's scientists out there that are doing research, and they need to communicate what they're doing with everybody else. The people who need to know, or people that want to know. Okay. Their peers, other people at academic institutions. All right. Well, you're at an academic institution. So right now, technically, you're a peer. Okay. So you're going to go find one of those articles. I always tell students, especially in the lab setting, you have written your first lab report. You'll find that these research articles are structured very close in format to the lab reports that you write. They'll have abstract, they'll have procedures, they'll have data, they'll do some analysis, and they'll give some conclusions. All right. So there's a relationship between the lab reports that you write and these research journal articles that you're going to be looking for and reading, because they're formatted the same. Okay. And it's intentionally done that way. All right. So, you can think of these research articles as fancy lab reports. So you're looking for one of these fancy lab reports written by a scientist who actively did research and is sharing it with the rest of the world. And your job is to read that article and tell me what it's about in your own words. Okay. And then you have to tell me, how does it relate to the stuff that you're studying in the lab class? Well, you're going to be doing more and more experiments, right? And so, the more and more experiments you do, the more and more things you are learning about, the more you'll see that there are connections between the article and the stuff you've done in class. All right. And we'll talk about these connections when I talk about the writing. We'll talk about that a little bit more then. But for now, I'm just trying to paint a picture in your head of what is it that you're looking for. All right. And then, of course, if you're in lecture and lab, you must do 2 different projects. So if you're in lecture and lab, you're looking for 2 different articles. I will not let you use the same article for both classes. You're not allowed to do that. 2 different projects. So that's why it makes sense that I'm explaining it to you at the start of, week 3, because, well, you got to you got to get started with this, because if you're in lecture and lab, it's double the work, right? Okay.
Yes, ma'am, but you're basically just doing the same thing twice, just 2 different topics, right?
That's right. The instructions are the same. You're just dealing with 2 different topics, correct? All right. So what kind of topics can you deal with, right? So it tells you can choose articles from the field of mechanics, which is motion, which is a big part of what we study in this class, energy, waves, astronomy, or thermodynamics. These are the topic areas. So the article has to have some connection to these topics. And let me be very clear, from a science perspective, this is a science class. I don't want history articles. I don't want philosophy articles. I don't want economics articles. I don't want articles that deal with diseases and things like that. I want an article that approaches these topics from a physical science or physics perspective, because that's what this class is about. All right, so I don't need to know about the economic feasibility of wind power in Czechoslovakia. because that's economics or some other branch, okay? Or students' perception of motion in a first-year physics class. While it does deal with motion, it is dealing with it from an education perspective. I want it from a science perspective, okay? How do you find these articles? Well, you could use the college's electronic databases. Right on the left menu, there's a link to the RPCC library. You can click that link and utilize the electronic databases. And no, I'm not going to tell you how to use them. That's part of this project. I will not help you find an article beyond what I've communicated to you here. In here, okay? So it's your job to find it, because that's a skill you're supposed to be building.
I have a question.
Yes.
So I'm in the lecture and the lab. So when it comes to your article, like say you're gonna do one on astronomy. So what I guess what I'm trying to say is, can they both be on astronomy, just different articles? Or if you do two, like one has to be on energy and then another one can be astronomy?
They both can be astronomy, but they cannot be on topics that are similar in content. So you can't do two different articles on black holes. No.
Okay, thank you.
Yep. Okay. So back to finding the article. So you could use the college's the college library's electronic databases, or if you have access to the library at another college, maybe Southeastern is closer to you, and you want to use their college library to find an article, fine. Okay. Or you have privileges at some other library, Nichols or wherever. Okay. But you can use the electronic databases to find these research articles. And what the electronic databases are is like a big giant warehouse with bunches and bunches of articles in it. And you have to go in and search that warehouse and find an appropriate article. Okay. And I don't want you going out on the web online. I don't want you doing a Google search to find these things, because when you try to download it, they're going to try to charge you. And these articles can be very expensive, $30, $40 a piece. And if you go out there and pay your money and it's the wrong thing, I'm so sorry, but you just lost your 40 bucks. Okay? So don't do it. Because students think they're finding the correct things, and they're like, well, I thought it was the right thing, so I didn't have a problem paying for it. Well, when I tell them they can't use it and they out of $40, they won't scream. Okay? But I'm telling you up front. All right. So the college's electronic databases is an avenue to get an article free. Free. I like that word in this class. Free. Okay. Another avenue for finding articles is this Hindawi website. You click on the Hindawi website, it opens up. You can search for an article and you can download the full article from Hindawi. So, that's the Hindawi website. They got a search button. And if you search for an article, I'm not going to search for one. I'm just going to pull one, from one of these to give you, because I got to show you something. And so, the way you can go about finding an article on Hindawi is to click the search box and put in what you're searching for, and imagine it'll spit back all the articles that it has on that topic. And the thing is, you can get those articles free on Hindawi. Okay. All right. So free. And then I told you earlier when we first got to class, when I covered the announcement, that you can also use this app. You can download this app on your Android or iPhone or tablet or whatever. And the way you have the right app is, this is what the logo looks like. All right. So I've given you 3 options for finding an article. Are there others? Yes. And if you have another one where you can find a peer-reviewed research article at no cost, fine. But I've given you 3 ways you can find an article. Use whichever one you like best. Okay. The other thing that you need to know is that your article, the article, not your summary. I can't tell you how many times I get emails from students panicking. Ain't no way I can write 15 pages long. I didn't say you had to write 15 pages. I said your article had to be 15 pages. And then they're like, oh, I was so confused. Why? It says it right here. I didn't see that. Okay. So your article, the thing you're looking for has to be a minimum of 15 pages long, not counting the references. So let me show you what I mean by that. Okay. So here's an article, for example. All right. Okay. So how are you going to know how many pages? Well, you got to download it, and see, you can download it free. All you do is click on that little PDF button. You can download it. And notice it tells you how many pages long it is right up there in the top. This is 10 pages long. Well, right up top, I know that's too short, because if I scroll down and I find the references start on page 8. Well, in order for your article to be long enough, the references have to start on page 16. Because I said what? 15 pages long, not counting the references. So you can't count this page or anything that comes after it. So if, this one only has 7 pages of, quote, body or text that's eligible to be utilized to do the summary. You can't use their references. Okay. Do you understand that 15 pages long, not counting the references?
Yes, ma'am.
All right. So now you have to, before you begin any work, before you begin summarizing anything, you need to get your article approved. Okay. The deadline for getting it approved is Saturday, 13 March 2021. Let me be very clear with you. At 12:00, I'm going to bed, and I don't care who doesn't have an article approved. It's not 11:59 p.m. on the 13th to send me an article. It's 11:59 p.m. on Saturday, 13 March to have an article approved. And if you wait to the last minute and I can't get to your email because I'm taking care of all the folk that got there before you, oh well, because 13 March is better than a month away. And if you wait to the last minute, that's on you. Procrastination on your part does not constitute an emergency on my part. Okay? Just be clear on that. To get your project article approved, please attach the full PDF article. The full article is a PDF file, and email it to me. Okay? You email me your article, the full article, not a Word document, not a link to the article, the full article as a PDF attachment. I'll review it and tell you if it's acceptable. If it's acceptable, I'll tell you this is fine. Go ahead, you're good. Or if it's not, I'll tell you you can't use this article and here's why. Okay? And you don't want to wait till the last minute, because sometimes it does take a moment to find an acceptable article. And I get emails all the time from students. I can't find an article. I've looked through hundreds and I can't find one 15 pages long. And I just keep telling them, go find article 101 or 102 or 250. However many it takes you to go through to find one that's 15 pages long on the right topic, go do that. Okay? Keep looking. Happy hunting. Whatever. All right? If you don't get an article approved by the deadline, you automatically lose 20 points off the article grade. So 20 points off the top. That means the best you can do is 80%. All right? If you do not get an article approved, you can still do the project. Because I get students all the time saying, well, I didn't get an article approved. Can I still do the project? Yes. But be aware that there could be point deductions. beyond the 20 points. So you automatically lose 20 points off the top if you don't get an article approved. But let's say, for example, you're doing a project, but you picked the wrong kind of article. Your article is not approved and it's the wrong thing, because I've had it happen. Student didn't get an article approved. They picked something from a magazine. Well, that's not peer reviewed. Or it wasn't long enough. And I get students that say, well, I mean, can't you let it slide? I mean, it's, you know, it's 13 pages long. Isn't that long enough? Nope. 15 pages long, not counting the references. If you didn't get it approved and it's short, too short, 0. You didn't get it approved and it's on the wrong topic, 0. You didn't get it approved and it's not peer reviewed, 0. And I always get it. Man, I'm trying to graduate this semester and this project is going, you know, and I got to get a good score on this project and blah, blah, blah. And all this stuff has been available since day one. So I'm not going to cut you any breaks on that. All right. Any questions on finding an article or the consequences for not getting an article approved, all that kind of stuff? All right. So if you don't have any questions for me, I am done for today. While you're working, if you have questions, reach out to me. I'll be happy to address them. Otherwise, you're free to go.
When it comes to the project, how long does the summary have to be?
We're not there yet. Find an article and then we'll talk about that.
Yes, ma'am. Thank you. Have a good day.
All right. Jonathan, do you have a question for me? Jonathan, are you still there?